One of the things you'll have noticed quite rapidly when you start programming is that after a while you just cannot keep track of all the things you want to move around the screen. For example, you've got one character moving left and right across the screen, and that's lovely. But let's say they shoot a gun and you want to keep track of the bullets. There's no possible way that you can code for bullet 1, bullet 2, bullet 3 and so on. It becomes impractical. And if you look at this demo that I've got running on the screen at the moment, this is a sort of simulation of some fireworks or some other festive excitement. And you can see every single firework flies up into the air and then explodes in a pattern of dots and bits and pieces. And there's no possible way that I could code every single one of these individual objects separately. So the way around this is to use a rather interesting function of Pico-8 to use a table to create an object. Now this all sounds really quite confusing, but when you get started on it, you start to see that things are going to be fairly straightforward. So if I go to a normal screen like this and we start to look at the code, the first thing to remember is that Pico-8 can have a table. So I could say table T, and I could give it some values, 1, 2, door, if door is a variable, hello, and so on like that. So I can store all sorts of things in a table in Pico-8, and this is really, really handy for us, because actually one of the things you can store in Pico-8 are functions themselves. So what we're going to do is we're going to create a really simple table that's going to contain all the information it needs for a bullet object. So the first thing we're going to do is to add a function, and so it's a normal function, and we're going to call it add new bullet. And like any normal function, it begins and it ends, and so we have the classic function, name of it, and an end. And this function is going to add to a table called bullet some sort of values. So you can see here what we're doing at the moment is we're just adding an empty table, this bit, to another table called bullet. So straight away we realize that we need an init function at the beginning of our program, which is going to make sure that we declare our table bullet. So this is the table that's going to contain all the bullets, and we're adding into that table this empty table here. Now I'm going to push this down a little bit so I can actually get working. So the first thing I'm going to add to this bullet is an X location, and I might put it in the middle of the screen, and I might do the same for a Y. And you can see straight away I'm putting these commas in, and that's because each of these items is an item that belongs in this table. So X is 63, Y is 63, that's the middle of the screen. I'm going to put in a couple of speed variables. So dx is going to be a random value between -1 and +1. So if you know how to do that, we're just going to, I get random 2 - 1, and I'm going to do the same for dy. dy equals random 2 - 1. This is just a shortcut code of generating a number between +1 and -1. If you imagine if random 2 returns a 2, then we subtract 1 from it, we get a value of +1. If random 2 returns 0, we subtract 1 from it, we get -1. Anything in between -1 to +1, and this gives us movement in this direction and that direction, and the same for the dy. Okay, so we've got some pretty straightforward variables there, the sort of thing you might expect to see for a bullet. Now what's really clever about the way that we can use this is that we can also put in a function. Okay, and what we can do is we can make this function reference itself being the object that we've just created. And finally, we best give this a name, because of course everything inside a table has to be referenced. So we're going to call this one draw, and that's going to equal function self. Okay, and obviously that's going to have an end. And within this, we're just going to draw our object, our bullet. Now the only thing to say here is that the bullet, because we're referencing the variables within itself, we don't want to be pulling in variables from elsewhere. We just want self x, self dot y, and we'll draw it in some sort of color like white or something like that. Okay, and then need a comma there. We better have an update function as well. So update equals function self. Again, this is another function that's working on itself, and all this does is it goes x equals, so x plus equals dx, need some self dot. If you find it doesn't work, you've almost certainly forgotten to make sure that you've expressly said that these variables belong to the object itself. And self.y plus equals self.dy. Okay, so that's just moving our object in the classic way you'd expect. I've realized here that if I keep going like this, I'll have these objects disappearing off forever, and it's going to start churning on the computer. So I'm going to make sure that each object only lasts 20 turns. So I'm just getting a value called life, which is 20, and in here life minus equals 1, self again, self.life minus equal 1, and we just need to check the question if self.life less than 0. So in other words, if we've run out of life, then, and we just need to delete from bullet self. Okay, so we're just removing ourselves from the bullet table, and that is that. So that is an object that is going to generate a bullet. It's going to generate it in the center of the screen for the time being. It's going to move it in a random direction for a certain amount of life. It's going to draw it because it's got its own draw function here, and it's going to update it because it's got its own update function. So then within here we need a function draw, and we need a function update. I'm going to use an update 60, why not? And within these we have to go through all the objects that are in the bullet table and run their draw function or their update function. So in function draw we have to call the function that we've written here, this one, draw. So we're going to say for b in all bullet do, and again end because we're opening one of these statements, and in here I just have to say b draw. So in other words, we're going to call the draw function, and we want to do the same thing in update, but we want to call the update function here instead, which is this one here. We also probably need to clear the screen because otherwise it'll turn into a mess, and we need to actually fire the bullet, which I'll just do on a button press. So if button for then, so how on earth do we generate a bullet? Well, we called it add new bullet, so let's make sure we do. If we press button 4, add a new bullet. If we run it now and I press button 4, there are all my bullets flying off into the distance. So at the moment the bullets are flying in a random direction, and obviously if you were playing a game that's not very realistic. So let us instead get rid of that, and let's make the bullets just fly straight up the screen like a proper set of bullets. So their dx is going to be 0 and their dy is going to be -1, let's say. So that's straight up the screen, and let's make them last a little bit longer, 30 seconds. Okay, or not 30 seconds, sorry, 30 ticks. So if we run it now, they're a bit close together, aren't they? Let's make them move a little bit quicker. There's some bullets. Okay. What we could do is control this speed and direction. So let's, instead of just having plain old add new bullet, let's have add new bullet, and let's make it so that we can control the direction that they go. So we're going to ask it to pass a dx, and I mark it with an underscore to show that these are external ones, and a dy. So now the add new bullet function requires 2 variables, which are going to be its speed in the x and y direction. And now dx is going to pick that up, and dy is going to pick that up. So we're picking them up now from our function. So when the function is called, this area here is where we're going to pick it up. So if I at the moment make it 1 and 1, Then the bullets are going to go diagonally. If I run it, you can see the bullets going diagonally down there. Okay. So what we can do is we can control this with our directions. So I could put in here, if button naught, then this is going to be very poor programming, by the way. This is just trying to get this done for speed. So if I'm pressing button naught, which is left, then I'm going to say dx equals, which is left, -1, and I'm going to say dy equals naught. All right, and I'm going to grab this for all the others. And so for each of these, so for firing to the right, we're going to add 1. For firing up the screen, we're going to make sure x is 0 and y is -1 because we're going up the screen. And to go down the screen, x is 0, y is 1. Okay, and if I run that, I've got to put these into here, sorry, dx and dy. Okay, and we better just make sure that when the game is normal, dx equals, let's have it default facing upwards, so dx is 0 and dy equals -1. So if we run this, there they are facing upwards, left, right, down. So I've got a little bit of shooting going on there now. We still have this really rather annoying blank solid line that comes out. Now we can fix that with a delay, but we're starting to drift into the realms of not the function itself, but everything else. But if I just change these to, let's say 3. Okay, so I'm just going to make everything move that little bit quicker this time. So we can shoot up, left, okay, like that. And that is how you can make objects in Pico-8. It's very, very simple. You create a function, which you call add new object, or whatever you'd like to call it. You can pass that function variables if you like, if you want to calculate things outside the function. You then add, within this function, you add a new table to an existing table. So you declare a table at the beginning of your program for the object names itself. This is the table that's going to contain all our objects, or all our items. You declare a table here, which is the same as the one you declare at the beginning of the program. And this table will contain all the individual items of that type. In your function, you add a new item into that table. And within the item that you've added, which in itself is a table, you add variables for whatever you like. I've added speeds and directions, but it's anything. And then 2 crucial ones, you add an item, you see there's a comma and there's a comma, so it's a single item in this table, which is a function in itself. Draw function, acts on self. You reference any variables you need with the precursor self to make sure that it's identified properly. And this is then callable from outside within your main program by looping through all the items in the main table, the bullet table, by looping through all of them and calling that particular function. And we do it again down here, all the items in the bullet table, and we call the update function. And the update function is here. One thing to keep in mind, especially if you're creating a lot of particles, is to have some sort of variable that keeps track of how old the item is, so that if it gets beyond a certain length of time, it is removed. You could also have this remove things if they move off the screen and all sorts of other ways, but you remove it from the table, and the thing that you're removing is the item itself. So that is how to put into your programs a large number of objects and make them function autonomously. It's a really useful system to do this, and I've had a lot of fun using it. Happy programming.